Okay, all things inequalities here. Um, with one exception, and I bet it's an exception you know about, we solve inequality problems the same way we solve equations. So, for example, let's get a really easy example here. Let's suppose we have 3 plus x is less than 8. This always comes up, so let me address it. How do you remember which way this symbol goes? I have no idea how you remember. How do you remember your name? How do I remember anything in my friend's name? But at any rate, the little pointy side here points to the side which is less than. So this is red. 3 plus x is less than 8. And I'm going to solve this exactly as if that was an equal sign. So I'll subtract 3 from both sides, and I'll get x is less than 5. Let me do a little slightly more interesting problem. Let's suppose we had 3x minus 7 excuse me, equals, I can't think of a good example right now. Let's say equals 8, okay? No, not equals, greater than 8. How will I solve this? Add 7 to both sides and divide both sides by 3. The one exception is, let's suppose this had been a negative 3. And this had been a negative 3. And I'm sure you've heard this. But if you multiply or divide, this camera in okay spot. Let's see here. If you multiply or divide by a negative number, you have to switch the inequality sign. So then we would wind up with this. X is less than negative 5, because positive divided by negative is negative. Now, an easy way to see why that's true, just consider the following. I think you would all agree that 1 is less than 2. Now, let's suppose I want to add 5 to both sides. Add 5 to both sides. 6 is less than 7. No doubt that's still true. Let's multiply both sides by 2. 12 is definitely less than 14. However, suppose I multiply both sides by negative 1. Multiply both sides by negative 1. Negative 12 is less than negative 14. Well, that's not true. But if I switch the sign, it is true. So I think it's relatively easy to see why that's the case. Now, let me do another example and talk about the next issue with inequalities, because there is another issue that does not per se come up with equations. Let's say we had 2 times 3x minus 1 equals, it doesn't really matter, say 7. Let's do the distributive rule. So I'm going to do an inequality. Let's say less than 7. I'm going to solve this, like I said, exactly as if that was an equal sign. So I would do the distributive rule. No surprise there. Let's add 2 to both sides. X is less than 9. We'll divide both sides by 6. Of course, always reduce. 3 halves. Oops. Is less than 3 halves. Now, how do I express the answer? This is one way. You can say x is less than 3 halves. That's completely valid, and everybody understands what you mean. X is less than 3 halves, so we get that, and as far as I'm concerned, that's okay. You can leave the answer like that. Now, there are other ways to write the answer, which again, I'm sure you've seen. One way is to, quote unquote, graph this on a number line. Not much of a graph, nonetheless, it is a pictorial representation of the answer. So here's our number line, and let's just say here is 3 halves. Now there's a couple of standard ways of doing this. One is to have an empty dot and shade into the left, because those are all the numbers that are less than 3 halves. And by convention, if I leave the dot empty, I mean, not 3 halves, don't include 3 halves, but everything less than 3 halves. If this problem had been this, then by convention I would shade this in. That's one way to graph it. And the other standard way to graph it is, let's say here's 3 halves, and shade this in. And if I'm including 3 halves, I will use these square brackets. Square brackets. If, on the other hand, it had been just less than, I use the rounded brackets. There's still other ways to write this. So I'm going to make that empty there. Another way here would be to write it as follows. This is called set notation or interval notation. And this indicates that it's all numbers I don't want to say greater than negative infinity because we're not using negative infinity here as a number. This is just trying or is representing what we mean. What we mean is all numbers to the left of 3/2 and just keep on going. So there's no number negative infinity. And for example, if I wanted to graph this, let's say x is greater than 7, I would write down 7, and that's supposed to be an open parentheses there. And I would shade it in off like this, or I could write like this, 7, comma, infinity. As far as these methods here go, you should be aware of all of them and understand what they all mean. I will be using this graphing approach, interval approach, and just this sort of equation approach, if you will, freely. There are situations where one or another of these ways of writing it just seems more appropriate, or seems easier, or seems better in some way in given situations. Okay, so that's, there's really not much new there compared to, or to add on to, equations. But I want to do the following, this sort of problem here. And this is in, let me see what chapter this is in here. Where'd my cursor go? Okay, so I want to go over 2.7. And you should read 2.6. Make sure you read 2.6. Work the practice problems. I don't think that'll be that big of a deal per se. But 2.7 is inequalities and equations involving absolute value. So I'm sure you've all seen absolute value before, and it's written with these two vertical bars. And if I ask you what is the absolute value of -5, I'm sure you're all going to say 5. But what the heck does absolute value actually mean? Well, one way to look at it, maybe the best way to look at it, is these absolute value bars are asking you how far away from 0 is this on the number line. And that's really what I would like you to think for right now, is how far away from 0 is this number? So if I said this is equal, this is equal to 5, certainly, or -5, because 5 and -5 on a number line. So there's a number line. There's 0, there's 5, there's -5. Look, they're the same distance from 0. So that's why the absolute. What am I writing this down here for? What I really meant was, should I redo the video? Nah. Absolute value of 5 is equal to 5. The absolute value of -5 is equal to 5, and the absolute value of 5 is equal to 5 because both 5 and -5 are the distance of 5 from 0. The question you should have is, why bother with absolute value? And the real reason why we bother with absolute value, the really important reasons, you'll see in calculus if you get to calculus at some point in time in your life. You'll see where, oh, that's a really good idea to involve this. But we do want to cover it, and there's some limited uses for it, even in this course that we'll see later on. How can we get an interesting problem here? Well, here's how we get an interesting problem. Suppose I said the absolute value of 3x minus 7 is less than 8. How can we solve this? I think the best way to solve this is to think about, what is this question asking you, or what does all this mean? If I wrote this down, consider this. The absolute value of star is less than 8. What I mean is that star's distance from 0 is less than 8. Star is at a distance from 0 less than 8. If we have a number line, there's 0, there's 8, there's -8. Star would have to inhabit that region. It would have to live in that zone. What does it mean to live in this region, or to be contained in this interval? If you were living in this interval, we would know that you are somewhere less than 8, to the left of 8, but to the right of -8. You would have to be somewhere in that interval. So I could write down, and we are going to write down, star is less than 8, but that's not good enough. I mean, -1,000,000 is less than 8, because you can't be -1,000,000. So star is less than 8, and star is greater than -8. We have to have both of those conditions met at the same time. Let's go ahead and apply that to this problem up here. So again, what does this mean? It means this object's distance from 0 is less than 8. If you are closer to 0 than 8, it would mean that certainly you have to be less than 8. But and meaning at the same time or simultaneously, 3x minus 7 is greater than negative 8. And this is a compound inequality, and we'll solve it just as is stated in the book. And again, make sure you read this, but 2.6. How do we solve this? We solve each one separately. This is not very difficult, but let's just go ahead and do this. So 3x is less than 15, x is less than 5, and, so the and comes down along because we're solving two, although simultaneous, they are two separate inequalities. Let's add 7 to both sides. So 3x is greater than negative 1, and divide both sides by 3. So x is greater than negative 1/3. So we need, or we want, or the solution set is all the numbers which are both less than 5 and greater than negative 1/3. Here's where I think graphing the solution is pretty useful, or it adds insight. So on a number line, what are the numbers which are less than 5? We'll say here's 5, and it's got to be the numbers going off this way. And of course, what numbers are also greater than negative 1/3? You'd have to be to the right of this number. So if you have to be to the left of this number and the right of this number, you'd have to be contained in that interval. And the way to write this in interval notation is negative 1/3, comma 5. Again, there isn't, and there's other ways to write this. There's something called set builder notation, and I don't want to go down that road. We don't need that for this course. It's good and valuable. Maybe someday I'll talk about it, but not right now. Either of these two ways is fine to write it. And honestly, you also can write it like this. You could say, well, I could have just used that, but let's say x is less than 5 and just use the word and x is greater than negative 1/3. This is interval notation. This is a graph. And we don't really have to call this anything, but there's 3 ways of expressing the answer. Like I said, there are others. I don't foresee me really caring how you express your answer. At the same time, the reason I hesitate there is you should really know all of these ways. Some people may prefer this, some people prefer this, some people may prefer this. So you should be fluent and ready to handle all these ways. Now, let's suppose that instead of a less than, suppose this was equal to. Well, that would mean that whatever's in here is at a distance from 0 of 8. If you are at a distance of 0 from 0 of 8, it means you would either equal 8, no surprise there, or there's another option. You could be sitting at negative 8. So 3x minus 7 equals negative 8. And we could go ahead and solve this, add 7, divide by 3, x equals 5, or notice the math is the same as we did last time. Add a 7, negative 1, divide by 3, negative 1/3. So x could equal either one of these two numbers. Now the graph here seems, I don't want to say silly or a little bit trivial. Nonetheless, this is what the graph would look like. It's just 2 dots, represents 2 numbers. Now interval notation for this is, you wouldn't normally see people use this, or at least I wouldn't normally use this. How do I represent the number 5 in interval notation? Well, it would look like this. This feels a little weird writing this down. It looks like that. It's all the numbers including 5, between 5 and 5. And the only number that's between 5 and 5, including 5, is 5. So that's how you write 5 down. And this is how you write negative 1/3 down. And we want both these, so we use that capital U, which means union. All these together with all these, we combine them together. Again, that seems, I don't know, a bit odd to write it like this. You can, it's perfectly valid, but it definitely feels strange. Okay, now what if instead of less than or equal than, what if up top here we had greater than? Well, that means that what's inside the absolute value is further away from 0 than 8. And if you're further away from 0 than 8, Well, on the one hand, you just be greater than 8, and that would put you at a distance greater than 8 from 0 than 8. Or there's another option, and that is you could be far off to the left of negative 8. You could be way down to the left. We have way down, but to the left of negative 8. And let's go ahead and solve these. The math is the same. Add 7 divided by 3. X is greater than 5. Or add 7 divided by 3. X is less than negative 1/3. How would I graph this? Let's see. X is greater than 5. There's 5. We'll shade everything going off in that direction. That's everything to the right of 5. Or we'll go to the left of negative 1/3. We'll do this. You could leave the answer like this. You can leave it like this. Now, interval notation is a little more interesting here. Negative infinity to negative 1/3. That's everything to the left of negative 1/3. Together with, so union, together with everything greater than 5. So these are kind of nice problems. Now, on these particular problems, I'm really interested in making sure that you understand that absolute value means distance from 0, and what are the logical ramifications of that. Again, if I say that something, and it could be anything, let's say I said that W is greater than 9, it means W is further away from 0 than 9. So either W is less than negative 9, or, and you do use the word or, W is greater than 9. If I said the absolute value of T is less than 9, well, I mean, T is closer to 0 than 9. So that would mean that T would have to be greater than negative 9 to the right of 9. And at the same time, T has to be less than 9. And if here's another line. There's 0, 9, negative 9. You have to live in that region. T would have to live in that region right there. And to live in this region right here, you're to the right of negative 9 and the left of 9. Okay, so let me see here. As far as chapter 2 goes, we're going to skip 2.4. So let me write that down. For now, we should make everybody pretty happy, I think, right now, because what I'm saying is we're skipping word problems on this first test. Plenty of word problems in your future here, but we're going to skip them for right now. So skip word problems for now, temporarily. And those were found in 2.4. Now, if you study 2.4, good, because we are going to go over that. So you didn't waste any of your time or anything like that, because we are going to cover this, but this will not be on the first exam. Okay? So again, any questions on chapter 2, be sure to send them to me. I just got some sort of weird pop-up here. I don't know what that is. But at any rate, okay, that's this video. Now we're going to head to chapter 3. So for now, goodbye.